Okay, gentlemen, what we looked at last time was this. We saw that if I have a point on a circle, and I don't say, and these are not my radical 3 over 2 and 1/2, these are different numbers, and I figure out which quadrant I am, quadrant 3, and then I label my points, my x and my y in quadrant 3, my hypotenuse, if I do the math, if I square both sides, we did that, if I square this and I square this, I would get 1 for my hypotenuse. We saw it up here as well. I get 1 for my hypotenuse, and we said that was an important identity. So we're going to write that identity in our notes. This is on page 9. Sine squared theta plus cosine squared theta equals 1. We have to know this identity. That's one you have to memorize. Using that identity, you can get 2 other ones. These are used to rewrite equations all in one trig function. Right? So if I give an equation with sines and cosines in it, I'm going to want to use this to try to convert everything into just sine or just cosine. But it's useful to have another method. So if I divide everything by cosine squared, for example, I'm not changing the equality of this statement because it's still, I'm dividing everything by the same number, but I can rewrite sine over cosine as tangent squared. Cosine over cosine is 1. 1 over cosine is my reciprocal of cosine. So secant. So this is my second one. I usually don't have this memorized. I just solve it. So on a given test or quiz, I'll write down my yellow one, and then I'll mentally divide everything by sine and divide everything by cosine to get the other 2. Because sometimes equations don't always have sine or cosine. They could have tangent in there. So maybe I want to rewrite an equation so everything is in tangent, or there's a secant squared. So I want to rewrite that in the form of tangents. So sometimes there's a benefit to rewriting the equation, and this is what we would use them for. Sine over sine. Cosine over sine is a reciprocal of tangent, and then the reciprocal of sine is cosecant. So there's my 3 functions. Number 1 you have to know, and then number 2 and 3 I just derive each test or quiz. Okay, so now we're going to see how to use this. In the notes from last, like the last homework, you had sine squareds and cosine squareds on number 1 and number 5, but they didn't have any other trig functions. If, for example, we have to solve for theta on this equation, sine squared theta plus 2 sine theta, okay, looks the same as last class, equals cosine squared theta from negative pi over 2 to pi over 2. How does this differ? Well, I have a sine squared, a sine, and a cosine. So now I'm not all in one trig function. My goal would be all in one trig function. So I'm going to use my identity. I'm going to use my yellow, most important identity. I have a sine squared. Okay, that's good. I could make that x. I have a sine. Okay, I could make that x as well. But I have a cosine. I don't want to make it a y. What do I do with the cosine squared? Well, looking at my Pythagorean identity up here, if I rewrite cosine squared as cosine squared equals 1 minus sine squared. So I just took my identity and I just moved the sign over, right? I'm just shifting the sign over. So now I have cosine squared is equal to 1 minus the sine squared. Since I know that, what I can do is replace my cosine squared with 1 minus sine squared. Now I have rewritten the equation not changing any values, with everything in terms of sign. So that's the goal of these trig identities. This one's going to have sine squared plus cosine squared is 1, but you could have sums with tan and secant, or cotan and cosecant. But often it's this format. Okay, so now that I have everything in forms of sine, I replace everything, all the signs, into x's, and I follow the same procedure as we had last class. I'm going to do this a little quicker since you can pause the video. I have 2x by moving the x over. My 1's cancel, so I get 2x squared plus 2x equals 0. So I moved over the x squared, moved over the 1. Take out a 2x, I have an x plus 1. This left-hand side is equal to 0, and this right-hand side is equal to -1 by factoring. Put my signs back in. Sine of theta is 0. Sine of theta is -1. This is saying what is the angle for sine that gives me 0. So that was just like my inverse sine of 0, but we use the phrasing arc sine. That is next year's phrasing. So arc sine of 0 equals what? And same over here, arc sine of -1 equals what? That's what we're solving for, the arc sine or inverse sine. 0 and 1 are going to be some of the quadrant lines. So I'm going to put points all over. Okay, then I'm going to look at my domain restriction. This over here says quadrant 4 to quadrant 1, from -pi/2, which is 90, -90, up until pi/2. So this is my way of saying the right-hand side, quadrants 4 and quadrants 1. With these, because I'm starting going negative, if you get an angle that falls in here, you don't want to call it something like 330 or 300. You'd rather say -30. That's the only difference with this kind of a domain restriction. When I say I'm from quadrant 4 to 1, you're going negative then positive. So you're saying from your, and you're continuing the same direction, right? You're going clockwise, but I'm saying from here to here. So you want to ideally stick within that domain restriction. You don't want to go outside and come back in, because you're starting negative and then going positive here. So I'm looking for where are my 0 and 1. Here's 1 and 0. Here's 0 and -1. That's outside my domain. Can't use that one. Okay, when is sine -1? That is when I am -1. So I would call this angle -pi/2. Right? I wouldn't call it 270 because in my domain I have -pi/2. So I'm saying I'm going to call it this way. I'm not going to go all the way around. Both are technically correct, but because my domain lists it as -pi/2 to pi/2, I'd rather say 270 as -90. And then where is sine 0? That's here. I could say 0 or 360, 2 pi. But again, 360 would kind of allude to the idea that I'm going all the way around and coming back. 0 would say stay put, don't move. So I would more likely say 0 is the correct answer here. So my two answers are -pi/2 and 0. You only have these little issues with your domain like this when I'm quadrants 4 and 1. If you look at the previous video, if I say, pi/2 to 3 pi/2, I'm going to, start outside then exist in my domain. But my terminal side with these two, ideally we're going to go kind of just stick with in here if we can. Okay, our second example is cosine squared theta plus sine theta equals 1, 0 less than theta less than or equal to 2 pi. So I'm all the full length of the circle, except this point I would call 2 pi, I would not call 0, because I didn't include 0. I'm including the 2 pi, not including the 0. They're the same point. This is me telling you which one I would consider correct. So not 0, but I would say 2 pi is included. So start at 1 degrees technically. Okay, so scroll, kind of zooming out a little bit. We're going to do the same thing we did last time. I have a sine and a cosine squared, so I want them to be the same trig function. I don't have anything for sine squared, so I can't do anything there, but I do have this cosine squared, so I'm going to do the same thing I did last time. 1 minus sine squared plus sine of theta equals 1. Rewrite everything in x's, because now I have all signs. Subtract 1, it goes away again. Negative x squared plus x equals 0. Take out an x, I have negative x plus 1 equals 0. X equals 0. Negative x plus 1 equals 0. X equals 1. So very similar to the last problem, I have x is 1 and x is 0. I'm going to label all my points because I can be anything. This is 1, 0, 0, 1, negative 1, 0, and 0, negative 1. Sine, all right, so this is arc sine of 1. When is sine my y value 1? That's up here, so that's at pi over 2. Similar to last time, I'm going the whole way around the circle, so I could call this negative 90, but I would more likely say, let's go positive. I'm kind of saying the whole circle from 0 to 2 pi, so I'm going in this direction. I'm not really alluding to going negative at all, so I'm going to say 90. When is sine 0? Sine is the y, sine is 0 here and here, so I'm going to say it's 0 at pi over here. And also over here, which we said we're going to call that 2 pi, because my domain restriction tells me 2 pi is yes, 0 is no. So those are my 4 answers: pi, 2 pi, and 3 pi. Good luck with the assignment. I think you have about 3 examples to do.